Locate zeros of a function. And specifically what we're talking about here is locating where the zeros of a function may lie when we're looking at a table. And this is particularly true when one of the zeros or the solutions is not an integer, a whole integer, let's say. But it's between two consecutive values of x. And what we're going to see here in a few moments is when we look at the table, when we have consecutive values of x, where the y values associated with those individual consecutive integers, we'll see it change signs. It'll go from negative to positive or from positive to negative. In other words, as you think about it, if you're coming, you've got a positive value, you hit the x-axis, and all of a sudden y goes to a negative value, well, you're going to see it change sign. And if it comes back up and crosses the x-axis again, you're going to go from y being a negative value to a positive value. And between those integers, if that's where it happens to lie, it's going to be a zero of the function. Now again, here's our function in this case: x to the fourth minus 3x cubed minus 2x squared plus x plus 1. And again, there's things that we could determine that's going to be associated with this function. Exponent is an even number, means that the end behavior is going to be going in the same direction. This is a positive x to the fourth, so our end behavior is going to be going up. It's going to be arms up. Both left and right end behavior is going to be going towards infinity. We could have possibly 4 real zeros, or we could have 2 real zeros, or we could have no real zeros. We'll learn more about that a little bit later on, but the most real zeros we can have are 4. There will be 3 turning points in the function. That's always the exponent less 1. Although in some of these higher value exponents, sometimes it can be hard to see unless you get the graph really large and zero in on a specific function, because it may just be a little wobble in there. And obviously here also I'm going to have a y-intercept at 1, just for the fans, just to know that that's going to be the case. So let's move over here to the calculator, and we're going to demonstrate this thing about consecutive integer values where a real zero may lie. Now, as you can see here, I have entered that function, x to the fourth minus 3x cubed minus 2x squared plus x plus 1. And let's jump over here to the table and see what we can see. So I'm going to hit second graph, and it brings up the table. Let me scroll this down a little bit. There we go. All right. Now, if you go back up here to where x is equal to 0, and everything above that, all those negative numbers, I've got positive values, and then you can see they're getting quite large. By the time x is -5, y is 946. But here at 0, y is 1. But when x is 1, y is -2. Notice the change in sign. We've gone from a positive to a negative, and that tells us that somewhere between 0 and 1, we have a real zero. We're crossing that x-axis. And then if you look down just a little bit, when x is 3 and y is -14. Hello. No, it's not. Get off the phone. When x is 0, y is 1. And when x is 1, y is -2. And again, we've gone from this time from I already did 0 and 1. That phone call threw me off. When x is 3, y is -14. And when x is 4, y is 37. And again, between these two consecutive integers, 3 and 4, we've changed signs. We've gone from a negative number to a positive number, which again means that we are crossing the x-axis. So in specific answer to the question, determine where the consecutive integers are. Well, they're between 0 and 1 and between 3 and 4. Now let's go take a peek at the graph and see if that holds true. All right, so here's the graph, and I can see that we're crossing the x-axis. We almost do right there. But between 0 and 1, and it's actually closer to 1 than it is to 0, we cross the x-axis. And then between 3 and 4, and it looks pretty close to halfway between axis 3 and axis 4, we cross the x-axis again. And before we leave this, notice what our end behavior is. On our left end, we're going out to infinity. Our right end is going out to infinity. That's why we have the leading term is raised to a exponent that is an even exponent. And I can even almost see the terms here. I can see two of them for sure. There's one, there's two, and there's one down here somewhere, although it's below the scale where y equals -10. So somewhere down in here, we make another turn. That would be the 3 turns associated with polynomial function raised to the 4th power. And this would be this is going to be a relative minimum. We're going to talk about minimums and maximums next. That's going to be a relative maximum right there on that turn. And down here, wherever this one is, that's going to be an absolute minimum. Just a little prep for what's coming ahead.